Hello students, I welcome you all in the session of non-conventional machining process. Today we will discuss about non-conventional machining process and conventional machining process. What is the basic difference between conventional and non-conventional machining process, and detail about electrical discharge machining process. In conventional machining process, there is a direct contact of a tool with the work. Take an example of a single point cutting tool while machining on a lathe machine. There is a direct contact of a single point cutting tool to the workpiece. But in case of a non-conventional machining process, there is no direct contact of a tool to the workpiece. Take an example of a laser beam electric arc machining process. These are the examples of a non-conventional machining process. This is the basic difference between conventional and non-conventional machining process. In case of your conventional machining process, cutting tool is always harder than the workpiece. But in case of your non-conventional machining process, tool may not be harder and it may not be physical presence. Third comparison between your conventional and non-conventional machining process is tool life is less due to high wear, and in case of a non-conventional machining process, tool life is more as compared to your conventional machining process. Fourth parameter is general macroscopic chip formation. In case of your conventional machining process, we can observe that while machining process, chips will form during machining this process. Material remove occurs with or without chip formation in case of your non-conventional machining process. Fifth parameter is material remove takes place due to the application of a cutting forces in conventional machining process, but in case of your non-conventional machining process, it uses different energies like electrical energy, thermochemical, thermoelectrical energy, etc. to provide the machining process. Sixth parameter is the suitable for all machining process. Means conventional machining process is suitable to all machining process, means it is possible to the different materials also, but non-conventional machining process is not suitable for all types of a material. It depends on the process, which type of a process we are using, then it is not suitable for all types of a material. Seventh parameter is it cannot be used to make a prototype parts very effectively. Means it is not possible to make your parts accurately, precisely by using conventional manufacturing process, but in case of your non-conventional machining process, it can be used to produce the prototypes parts very effectively, accurately, precisely by using non-conventional machining process. First method we are discussing about in case of your non-conventional machining process, electrical discharge machining process. Another name of your electrical discharge machining process is a spark erosion process. It is also called as a spark machining process, thermal erosion process, or electro erosion process. This is the basic figure of electrical discharge machining process, which shows the various elements of your electrical discharge machining process. Firstly, we will discuss about construction of what is the basic principle of electrical discharge machining process. The main attraction of electrical discharge machining over conventional machining is that this technique uses thermoelectric process to erode undesirable material from the workpiece. Means erosion of a material will take place from your workpiece with the help of the thermoelectric process, and material is removed in the form of a small particle. It may get melted. This is the basic principle of electrical discharge machining process. Now we will discuss the construction of a electrical discharge machining process. What are the basic elements of your electrical discharge machining process? System which consists of firstly we will see that this is the main container. In this container fixture is placed. Main function of a fixture is to clamp your workpiece over the fixture, positioning the workpiece into the container. Next element is the tool. Tool is connected to the servo control motor. Then next is the power supply source. Dielectric fluid is also used and its circulation line. servo control tool feed mechanism, and workpiece. These are the basic elements of electrical discharge machining process. Now in this process, tool is connected to the cathode, means it is connected to the negative terminal, and workpiece is connected to the positive terminal. It is called as a anode. Terminals are connected to the DC power supply to create a potential difference between work and tool. This distance between work and tool is known as this is the distance which is provided between tool and the workpiece, which is known as a spark gap, and it is filled by dielectric fluid. This is the modified view of your tool and the workpiece gap, spark discharge gap, which represents the modified figure of your EDM process spark gap. Now we will discuss about the working of electrical discharge machining process. In this electrical discharge machining process, high voltage is applied between terminal and it induces electrical field in spark gap. Free electrons on tool are subjected to electrostatic force, and hence they are emitted from tool and accelerate towards the work. There would be a collision between the electron and molecule in dielectric. It causes further generation of electrons because of the ionization of dielectric molecules. This cyclic process increases concentration of electron in spark gap, and when the potential difference is sufficiently high, dielectric breakdown and no large number of electrons will flow from tool to job and ions from job to tool from this location. This movement of electrons visually seen as a spark, and electrical energy is dissipated as a thermal energy of a spark. With a very short duration of a spark, temperature of electrodes rises locally to more than their normal boiling point, and this heat of a spark melts a tiny bit of a metal from the work. The melted metal cools and solidified as a tiny particles in a dielectric. The metal is carried away due to circulation of a dielectric by means of a pump, and process continues. Next represents process parameters of electrical discharge machining, means which are the basic parameters which is required to carry out the process of your electrical discharge machining. While machining, voltage which is supplied, it is around 40 to 300 volt, current supplied 0.5 to 400 ampere, spark gap between tool and the workpiece is 0.0125 to 0.125 mm. It is in mm, means small gap is provided between your tool and the workpiece. Pulse duration is 2 to 2000 microseconds. Material remove rate, it is 800 mm³ to 5000 mm³. And what are the basic applications of this electrical discharge machining? Electrical discharge machining, which is useful to drill very small holes, and EDM milling to machine complex shape. Electrical discharge machining can be used to make a part with irregular shape with precision for forging press tool, extrusion dies, cutting tool dies, etc. Means this EDM process is useful for creating prototypes, also to creating dies, mold making. These are the basic applications of a electrical discharge machining process. But there is a little disadvantage of this electrical discharge machining process, which varies according to the material. Thank you.